In this lesson, you will learn about tangents and some of their properties and solve problems using the properties. A tangent is a line, a segment, or a ray that touches a circle in exactly one point. In example 1, the tangent is line TX. The point where the tangent touches the circle is called the point of tangency. And in this example, the point of tangency is point T. Now, a circle divides a plane into three different parts. There's the circle itself, there's the interior of the circle, and then there's the exterior of the circle. There are 2 points that are on the interior of this circle. There are points P and I, and there's one point on the exterior of the circle, that's point X. Point T, the point of tangency, is neither inside or outside the circle. It's on the circle itself. We'll learn a property of tangents, which is stated as this theorem. If a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. Now that means that whenever you have a line or a segment or a ray that is tangent to the circle, and that point of tangency is the end of a radius, then the radius and the tangent form a right angle or a 90-degree angle. We'll use this property to solve the problem in example 2. We're told that AB is tangent to the circle. The point of tangency is B, and we're asked to find X. Now notice that AB, it has a length of 12. The radius has a length of 5. And we will use the Pythagorean theorem to solve this problem, since we're asked to solve for X. We need to notice that because of the property just stated above, there is a right angle or a 90-degree angle at point B. That means we have a right triangle with 2 known sides, BC, which is 5, and BA, which is 12. We'll use the Pythagorean theorem to find the missing side of CA, so we can then find X. The Pythagorean theorem is stated as a squared plus b squared equals c squared, where a, b, and c are the sides of the right triangle. The first step is to decide which side of the triangle is C. It is always the side across from the right angle. So in this case, it is side CA. So we will find C so we can then find X. So we'll use the numbers 5 and 12 for A and B. So now the Pythagorean theorem says that 5 squared plus 12 squared equals c squared. We'll do the math. So 25 plus 144 equals c squared. We'll add 25 and plus 144. That's 169, which is c squared. To find c, we'll take the square root of 169, and so c is 13. But 13 is the entire length of CA. We just need the length of X. But a portion of CA is a radius of 5. So we will find X by subtracting 5 from 13, so X is equal to 8. Now we'll learn another property of tangents, which is stated as this theorem. If 2 segments from the same exterior point are tangent to a circle, then they are congruent. In other words, if you start with a point outside the circle and draw two lines from the point to the circle so that they just touch the circle at one point, then those segments from the point to the circle are equal to one another. So we'll use this property to solve the problem. In example 3, we're asked to find the value of x. But because QP is equal to RP, then we can write an equation 2x minus 3 equals 27. We can solve the equation adding 3 to both sides. That leaves us 2x equals 30. And then dividing by 2, so x is equal to 15. So we used the theorem to solve the problem. Another property that we need to keep in mind is that when circles are inscribed in polygons, then the polygons are said to be circumscribed polygons. Inscribed means to draw within. To circumscribe means to draw on the outside. So the circle is drawn within the polygon so that the circle touches each of the sides of the polygon. And so in these kinds of examples, diagrams, each side of the polygon is said to be tangent to the circle. So let's look at example 4. Triangle TRW is circumscribed about circle A. If the perimeter of this circle, or of the triangle TRW is 50, we'll use that to solve the problem in a moment. But let's label the diagram with the information that we're given. We're told that segment TK is equal to 3. We're told that segment WM is equal to 9.5, and we're asked to find TR. Well, because of what we know about tangents drawn from a point outside the circle, then segment TK is equal to segment TL, and segment WM is equal to segment WK. And we'll label segments LR and MR as X. Now we'll use those numbers and letters to write an equation to equal the perimeter 50. So 2 times 3 plus 2 times 9.5 plus 2 times x equals 50. We'll solve this equation by combining like terms after we multiply. So 2 times 3 is 6, 2 times 9.5 is 19, plus 2x equals 50. We'll combine 6 and 19, that's 25, plus 2x equals 50. Then subtract 25 from both sides, so 2x equals 25, and divide by 2, so x is equal to 12.5. So x is 12.5. We'll add to that 3 to find the length of TR. So 3 plus 12.5 equals 15.5, and we solve the problem. Now let's use the information we're given about the diagram in example 5 and the theorems that we've just used in previous examples to find the missing measurements in example 5. But first, let's label what we know. QA in green is 12, or OA. OB is 6, labeled in purple, and angle BAC is 60, labeled in red. Well, we notice that OB is a radius. and OC is a radius. OB is 6, so OC is also 6. ED. ED is a diameter, which is made up of 2 radiuses, which are each 6. So 6 plus 6 is 12. ED is equal to 12. AB. AB is a line drawn from an external point that is tangent to the circle at point B. And we know from a previous theorem that there is a right angle at point B. We'll use that to find AB. We'll use a squared plus b squared equals c squared. Side OA of that right triangle is going to be C in our formula because it is across from the right angle. We'll then use 6 to be A, and we're looking for side B. So 6 squared is 36, and 12 squared is 144. We will subtract 36 from both sides, so b squared is 108. We'll take the square root of 108, and that is equal to 10.39. So AB is approximately 10.39. Now we'll find AC, but AC is tangent to the circle just like AB, so it has the same length as AB, so it is also 10.39. Now we'll find angle BAO, which is 30 degrees, since it is half of the 60-degree angle BAC. Then we'll find angle OCA. OCA is 90 degrees, since it is the angle formed by the radius and the tangent OC. Then we'll find angle AOC. AOC will be found by taking 180 degrees, since that's the total number of degrees in a triangle. We'll subtract the 90-degree angle at point C and subtract the 30-degree angle that is angle OAC, and that gives us 60 degrees for angle let me back up. The 30-degree angle is OAC, and we're looking for AOC, which then will be 60. Then angle EOC is the same as angle AOC, so it is 60 degrees. And now we're looking for EA, which is 6, which we get by subtracting 6 from 12, since OA is 12 and OE is 6, EA is also 6. So we use several properties of tangents to solve problems in this lesson.